welcome again. So today I'm going to continue in the talk about quality, and now we're going to be looking at quality characteristic, the terminologies for quality, and the history of quality control. So now before I go on to the quality characteristic, I would like to say that I'd like to explain what target or nominal value is in quality management. So this is basically something that speaks to the benchmark or the goal that a producer or designer is seeking to meet in a product. So it's a benchmark or goal sought after in a product. It is kind of a desired value for a quality characteristic. It is the value of measurement that a designer seeks to achieve for a quality characteristic during production or performance. So quality characteristic can speak to maybe the length, the size, the weight, the look and feel, the function, based on what we have seen in the dimension I spoke about in the previous video. So the target value is more like the benchmark. This is the length that I want this product to have. This is the weight. This is the height that this product should have. This is the way this product should look like. That is the standard. So this basically is what target value is all about. And now it is also important that we note that no product are no two products are ever identical, and that is where variability comes in. Variability speaks to the differences that exist in product, and producers, manufacturers, businesses always seeks to ensure that this variability is as low as possible, because customers would always reject and will not affect products that are very large in variability. Imagine I go to buy a charger, right? A charger head, and the or should I use a laptop? Let me use a laptop now. Now I'm going to the store to buy a laptop, HP laptop or a Dell laptop, whatever laptop you're interested in, and then you get there, and the laptop certification that you have, maybe you have HP Pavilion or whatever HP you have right now. You want to buy the same exact laptop again. Now consider that you now get to the store, and then they say the laptop is exactly the same one as the same one you've had before, and the laptop is now looking a little bit bigger. It's way different from what you have seen before, what you are currently using, and they claim that this is the same laptop that you had before. So in such a situation, you wouldn't accept that kind of product, because it's number one, the difference is so very glaring. We all know that yes, no two products are ever identical, but the differences, the variability in this product shouldn't be very, very visible. It should be negligible. It's not something that customers should be able to trace or see. For example, if you are buying a fan, right, and you see in the standing fan that a blade is two times the other blade, you will begin to question and be like, didn't the producer measure this blade before he brought out this fan? Right? Didn't he go through the control measure? Didn't he go through the quality measure to check to confirm that this blade is in the right size? So variability cannot be removed, but it can be reduced. It might not be zero, right? It might not be able to be removed totally, but it should be ensure that variability is reduced to as low as possible, to as very small as possible. So customers would, as I already mentioned, that customers may not accept the product if the variability is really significant, if it's really large. Now, sources of this variability, these differences include differences in material. We all know that materials that you purchased in the past might not be the same or identical to the ones that you have purchased now from a production perspective, right? So this variability is caused by differences in materials that are being used in production, differences in performance, differences in operation of the manufacturing unit, right? Now, those are the causes of variability. And if you're looking at it from the service perspective, right? For example, if you have an employee that is your customer representative, maybe you have just one customer representative, and the customer representative is knowledgeable, has quality mindset, is serving customer in a very appealing way, where customers that have interactions with her always have a good experience. And by the time you change this customer or you transfer this customer rep to another location, and another customer rep comes in, variability might occur because they have different mindset, they have the same different background, they have different experiences, So these are the reasons or sources of variability. Differences in materials, whether human capital or physical materials. Now, specification also speaks to the detailed description of the desired characteristics. We all know that whenever we want to purchase some items, the list out in specification is going to do this. It's going to it has this length, it has this breadth, it has this camera size, it has this camera features and the like. So the specification in terms of quality characteristics, it speaks to the detailed description of the desired characteristics that you want to have in a product. Now, we're going to be looking at the next one, which is important terminologies in quality management. Okay, we have the upper specification limit, which is the USL. We have the lower specification limit, which is the LSL. The upper specification limit is the highest range or the highest allowable value for a quality characteristic. That's the highest your quality characteristic can go. Remember, we have a target. There has to be a target in each of the quality characteristics. So the upper limit just tells you this is the highest your product can go. In terms of the quality characteristics, say for example the height. If you are producing something and your target is 30 centimeter, the highest that chair can go or that table can go is 32 centimeters. That is the upper specification limit. And then the lowest specification limit speaks to the smallest allowable value for a quality characteristic. Now I'm going to give an example. But before I give an example, I'll move on to the non-conforming product, which is seen as being defective. Any product that doesn't meet one of the specification is considered as defective. A defect is the non-conformance to the specification that has been put in place. An example is a chair. Let us consider the quality characteristic to be the length and the height. For the length, you have a target length of 30 centimeter, and you've said that your highest allowable value for this length is 32 centimeter and the LSL is 28 centimeter. So a chair that is having the length between this range is considered acceptable. Also for your height, a chair that is considered having a height between this range is also considered as acceptable. So now I'm going to be drawing a graph to explain what I mean by just so that I drive home the point. Now let's consider this example as we saw in the previous slide. The target length for this quality characteristic for this chair is 30 centimeter, but if it falls at 32, it's still acceptable. If it falls at 28, it's still acceptable. And also for the height, if it falls at 40 centimeter, it's also acceptable, being our target. And if it falls between this range, it's also considered acceptable. So I'm going to be drawing so that I also explain what I mean with a graph. Okay, so now here we have our target, which is our, we are going to be looking at the length now. This is our target, which is 30, and over here we have our LSL, which is 28 centimeter, and over here we have our 32, which is our USL, which is 32 centimeter. So the range here between here and here is 2 centimeter, 2 centimeter, and between here and here is another 2 centimeter. So these are the variability. This from here to here is the variability that exists. Is from here to here, the variability in terms of it being higher than the target, and the variability here in terms of it being lower than the target. But if the product falls between this range, this variability level, it is considered as being acceptable. Remember, this is the LSL and this is the USL, and then we've also established the variability being this 2 centimeter lower than the target and 2 centimeter higher than the target. Yeah, so let's quickly move on to the next one, considering some examples. Now we're going to be also looking at this review. So if a chair has a length of 32 and a height of 37 centimeters, remember, even if the defect is in one aspect of the criteria, it is considered as being defective. It has to go through the manufacturing process again to be adjusted. Now this chair has 32 centimeters and a height of 37 centimeters. Because because it is lesser than the lowest allowable measure, it is considered as being defective. It has one defect based on the height. Now, if the chair has 33 centimeter length and 39 centimeter length, it's considered as not acceptable because the length is outside the range that we have specified for the product. Now, if the chair, sorry about that, if the chair has a length of 34 centimeter and a height of 30 centimeter, across the two quality characteristics, it is not conforming and is considered as being defective. Now, for a chair that has 32 centimeter and 38 centimeter height, length and height respectively, it is considered as being conforming and has no defect and would be allowed to go on to the customer, sold to the customer. Now we're going to be looking at the history of quality control, and a lot has happened so far. And concerning the history of quality control, a lot of things has been put in place, a lot of implementation, a lot of teams have come together, a lot of departments has been established, a lot of product and materials have also been put in place to ensure that quality is maintained across board, across all interaction. In 1875, scientific management principles divide work into smaller, more easily accomplished tasks, but also introduced, and this focused on productivity. In 1900 to 1930, this productivity and quality was improved on by Henry Ford. And he developed self-checking and in-process inspection. And moving on to 1907 to 1930, within this time period also, AT&T began systematic inspection and testing of products and materials, right? And Gossett also introduced the distribution result from his work on quality control, distribution in terms of test statistical method from his result from his work on quality control at Guinness Brewery. Now in 1915 and 1919, British government began a supplier certification program to sort of drive or change the behavior or address the behavior to make sure that every manufacturer supplier ensures that they maintain quality, to ensure that they maintain the quality that they have stated in their policies. Now in 1920s, AT&T Bell Laboratory also formed the Quality Development Department, emphasizing on quality, inspection, test and reliability, product reliability. All of these were done to sort of maintain quality and control quality. Now 1927, Stewart introduced the quality chart concept in Bell Laboratory Technical Memorandum. Now we're going to be also looking at the acceptance sampling methodologies that were developed by Dodge and Rummy at Bell's Laboratory in 1928. Stewart published Economic Control of Quality and Manufacturing Products, outlining statistical method for use of in production in 1931. Now in 1946, ASQC formed a measure ASQC was formed as a measure of various quality society and international standard organization was founded. Deming was also invited to Japan by the Economic and Scientific Service section of the U.S. War Department to help occupational forces in rebuilding Japanese industry. A lot of things were done during this time in Japan, sort of like improve their quality, sort of like also improve the acceptance of their products by customers. In 1948, Taguchi began study and application of experimental design. Deming in 1950 began education of Japanese industrial managers. He did some statistical quality control method, which was widely taught in Japan as at that time. In 1987 as well, International Standard Organization published the first quality system standard. Yes, that's many organizations began to adopt. In 2000, supply chain management and quality supplier became even more critical factors, and it was also expanded beyond the traditional industrial setting into many other areas such as the financial sector, the bank services, healthcare, hospitals, insurance companies, and also other utilities. Yeah, so basically this is where I'm going to stop today. In the next video, we're going to be looking at a management aspect of quality part 2. Thank you so much and have a great time.